Hi, stats students. I'm going to go ahead and work out a few problems for you. First of all, I want you to skip 31 and 32. There's just too much algebra in those problems. That's on page 610. Remember, through this recording, you can pause at any time and listen to it again, or listen to it a number of times. First off, I want to do number 23. Number 23 says we've got 3 couples and they've reserved seats in a row for a concert. How many different ways can they be seated if there are no restrictions? So that means we're going to treat all 3 couples as 6 different people. So that's going to be 6 factorial, which is 720. Part B says the couples have to sit together. So since I have 3 couples, there's 3 slots for each couple. And then within each couple, you can have person A, person B, or person B, person A. So you're going to have 2 factorial times 2 factorial times 2 factorial for each couple, and then times 3 factorial for the different ways that the couples can be arranged together. And so that turns out to be 48. The next problem is 24. For problem 24, it says, how many orders can 5 girls and 3 boys walk through a doorway if there are no restrictions? So again, we just add them together. So that's 8 factorial, which is 40,320. And then part B says if all 5 girls go through first, so there's 5 factorial ways to arrange the girls and 3 factorial ways to arrange the boys. So when you multiply that out, you get 720. The next problem I want to talk about is problem 55, the poker hand problem. For problem 55, it says you're dealt 5 cards from an ordinary deck of 52 playing cards. In how many ways can you get a full house? A full house is 3 of one kind and 2 of another kind. So within a deck of cards, you've got 4 aces, 4 twos, 4 threes, 4 fours, 4 fives, and so on. So from any 4 that are the same, I need to choose 3. The order doesn't matter. And then in any other 4, I need 2. Well, that's part of it, but that's only getting one specific kind. There are 13 different numbers in the deck, so 13 different types of cards. So I need to multiply this by 13. So there's 13 ways I can do the first one, and then after that, there's 12 different ways to do the second one, because in a full house, the 2 groups have to be different. So like if these are all 8s here, these can't be 8s. These have to be 5s or kings or aces or something else. So when you multiply all of this together, you get 3,744. So there's 3,744 ways to get a full house. The last question I want to do is question 58. This is talking about paralegals. How many different ways can they hire 10 people? So there's 13 paralegals with 2 years of experience, and there's 20 paralegals with 1 year of experience. And the question says that we want to choose from the 13 with 2 years of experience, I want 7, and from the 20 with 1 year of experience, I want 3. So I'm going to multiply those 2 together. 13 choose 7 times 20 choose 3, and that gives me 1,956,240 ways. If there are any other questions that you have problems with, please send me an email and I'll be glad to go over those with you.